In this video, we'll be discussing rate, ratio, and proportion. Really, we're just going to be discussing rate because ratio and proportion are kind of the same thing. But, you know. Okay, so a rate is just a comparison of two quantities, and it can be written as a fraction. So, for example, let's say that we have a car is driving 180 miles in 3 hours. Its speed is really just a ratio. It's a rate of miles to hours, right? And so written as a fraction, this is 180 miles divided by 3 hours, or per 3 hours, which of course you could simplify to units that we're more familiar with, 60 miles per hour. So this right here is like the rate. 60 miles per hour is like the rate. Well, 180 miles per 3 hours is like the initial rate, and then this is like the simplified rate. You could also call this like a unit rate. Discuss that in the next slide. The corresponding ratio would be written like this. It would be like 180 miles and then a colon and 3 hours. So 180 miles to 3 hours would be the corresponding ratio. Of course, you could reverse the ratios a little bit. So you can, instead of doing miles to hours, you could do hours to miles, which would just flip the fraction. So 3 hours per 180 miles were written over here like so. 3 hours to 180 miles. These all are kind of saying the same thing though, and they'll be useful in their own specific circumstances. Of course, this is more useful in this situation because we're used to measuring speed in miles per hour, but in some situations it's more useful to flip it. Okay, so in the previous example, the unit rate was 60 miles per hour. 60 miles per hour, or 60 miles per 1 hour, is a unit rate because 1 hour is like a unit. So this is like 1 unit of time, basically. So unit rates are really useful for like a couple things. So like in particular, they could be useful for making comparisons between different similar ratios or rates, and they can be useful for other types of problems. So let's see an example of computing a unit rate. So here Justin's making $1,800 in a 40-hour work week. His unit rate in this problem is literally just going to be his hourly wage. So what is his hourly wage? Well, the rate is just 1,800 divided by 40 hours. And then we could simplify this. So what's 1,800 divided by 40? So you could use a calculator for this, or you could just go ahead and simplify. So I can cancel out a 10 from the top and the bottom, just basically doing that. And then what is 180 divided by 4? Well, I could cancel out like a factor of 2 from both of these. So this is like 90 over 2, and then 90 over 2 is just $45 per hour. So Justin is making $45 an hour. This is obviously really useful because, you know, if you wanted to like compare Justin's hourly wage with your hourly wage, if you're saying that you make like 1,600 in like a 30-hour work week, then like that comparison is kind of harder to, it's harder to compare 1,800 over 40 hours to 1,600 over 30 hours or 35 hours or whatever it is, without like kind of converting to like a unit rate. You know, if you're both working the same number of hours per week, then you can compare more easily. But if you're not, then unit rates is usually really useful. All right, here's another application of unit rates. So let's say that Mary can mow 360 square feet of grass in 40 minutes. How much can she mow in an hour? So we can start just by considering the ratio of how much grass she can mow in 40 minutes, and then simplifying this to a unit rate. So converting this to a unit rate is going to be really useful in this this scenario, this example, because 360 divided by 4, these numbers are going to work out like really evenly. So 360 divided by 4, you could cancel out a 10 from both of those and then just get 36 divided by 4, which is equal to 9. So the unit rate is 9 square feet per minute. And that's like how fast she can mow grass. And then how much can she mow in an hour? So she can mow 9 square feet per 1 minute times 60 minutes, which is equal to, well, 9 times 6 is 54, so tack on a 0, and you would get 540 square feet of grass. Note that the units of minutes are kind of canceling out here, and you're just going to end up with square feet. Okay. Also note that there's like a conversion going on here. Like this is like measured in hours, but of course we want to convert to minutes because our rate is in minutes. So in more complicated problems, you might have to like do some more conversions. Like maybe you're going from like weeks to hours or something like that. So you might have to like do some more conversions before being able to answer something a little bit more complicated. Okay. Let's say that Trader Joe's is selling peanut butter for $1.99 per 16 ounce. And Whole Foods is selling peanut butter for $2.39 per 18 ounce. Which is going to be the better deal? So this is going to be like a direct application of like what I was talking about earlier, where you just want to compare the unit rates. So $1.99 per 16 ounce versus $2.39 per 18 ounce. We want to convert both of these into just dollars per single ounce. Okay, and so I'm going to pull up my calculator here, just over on my computer. You can't see it. If I do $1.99 divided by 16, I'm going to get 0.124, so I'll just say 12 cents per ounce. And then if I were to instead do 239 divided by 18, so I'm literally just typing into my calculator like 1.99 divided by 16, and now I'm typing in 2.39 divided by 18, and over here I'm getting 13277 repeating. So 13 cents. So this is more expensive, and so you would want to go with the cheaper deal, which is 12 cents per ounce. So Trader Joe's has the better deal. It's not by much, right? But like it's still the better deal. And maybe there are situations where like you just need more peanut butter or whatever, and you know, but yeah, that's the better deal. All right, let's move on to exchange rates. So let's say that the Canadian to US dollar exchange rate is 0.74 Canadian dollars per US dollar. That should be accurate at the time of accurate at the time of this recording. Let's say that we want to convert 700 Canadian dollars to US dollars, and conversely, let's do the other way. Let's say we have 700 US dollars. How many Canadian dollars would that be? All right. So this is telling us that our rate is 0.74 Canadian dollars per 1 US dollar. Okay, so if I wanted to say like, okay, I have 2 US dollars, then it would be 2 times 0.74 Canadian dollars. So like anytime that you just have like a quantity of US dollars, you could just multiply that by 0.74 to get how many Canadian dollars that would be. So if, we'll do this one first. Let's say like we have 700 US dollars. We could just multiply 0.74 times 700, and then our units of US dollars would cancel out, and we would just get 0.74 times 700. 0.74 times 700, which my calculator is telling me this is equal to 518 US dollars. All right, conversely, if I wanted to know what like 700 Canadian dollars is in US dollars, so I start with 700 Canadian dollars, and then I can't multiply it by 0.74 anymore, because if I were to do that, let's copy paste that. If I were to do that, then my units are not going to cancel out. So like over here, the US dollars units are like being canceled out because you're multiplying by US dollars and then dividing by US dollars, or vice versa. Whereas over here, we're multiplying by Canadian dollars, dividing by US dollars, and multiplying by Canadian dollars. The units are not going to cancel out in the same way. So what we can do, though, is we can reverse this proportion, kind of like what I was mentioning earlier. So just reverse the proportion like this. So instead of saying you have 0.74 Canadian dollars to 1 US dollar, just reverse that information. Just say you have, for every 1 US dollar, you have 0.74 Canadian dollars. And now, so this fraction is still true. It's still like a true fraction that like for every 1 US dollar, you have 0.74 Canadian dollars. It's just now just flipped, which is more useful because now when we multiply it, it'll cancel our units. So instead of multiplying 700 times 0.74, you can take 700 Canadian dollars divided by 0.74. And so 700 over 0.74, 700 over 0.74, my calculator tells me, is equal to 945.9459, which I'll round to 95. So this would be equal to, 945.95 Canadian dollars. Awesome. Okay. All right, let's suppose that a bouquet of flowers has 240 roses and 360 tulips. Massive bouquet, whatever. Write the ratio of roses to tulips as a fraction in simplest form. So roses to tulips would be 240 roses per 360 tulips. So here there's really not too much to be done other than, this is a fraction. We want to reduce this fraction to simplest terms as much as we can. So reducing this, we would get, well, you can cancel out like a 10 from both of those, and you get 24 over 36 roses over tulips. I'm just going to write R and T for now. I could divide by 12 on the top. So 24 divided by 12 is 2, and 36 divided by 12 is 3. So we get 2 roses for every 3 tulips. And this would be in simplest form. Okay. Writing them in simplest form, it does always kind of have to come out as a fraction. So it could be like 60 over 1, like it was in that first example. It could be, if we reversed that, it could be like 1 over 60 in simplest terms. But you always want your numerator and denominator, if possible, to be represented as whole numbers or integers. And you would prefer them both be positive or both, or like only one of them be negative, depending on like kind of what's going on in the problem usually. So yeah, just writing your fraction in simplest terms is all really is here. Okay, now onto proportions. So we're just going to talk about the algebra side for like this and the next slide, and then I'll show you how to apply that to like a problem. All right, so let's just solve this proportion. 5 over 12 equals n over 18. Okay, so we're just trying to solve for n, right? So n is being divided by 18. And so if I just want to isolate n, all I have to do is multiply both sides of this equation by 18. And then we'll have n all by itself. N will just be 18 times 5 divided by 12. Yeah, let's see. And we could probably like simplify this a little bit too. So 18 divided by 12, you can cancel out like a 6 from both of those. So 18 divided by 6 is 3. 12 divided by 6 is 2. So we have 3 times 5 over 2, which is 15 over 2. Right? 3 times 5 is 15, and then just divided by 2. So n would just be 15 over 2. I will tell you my pet peeve with this. The book does this too, and it like blows my mind that it does this. So okay, all we had to do here was like just get n by itself, right? You just have to multiply by 18 and then you're done. There's just like one step you have to do. For some reason, a lot of people will do the following. So you start with 5 over 12 equals n over 18, and then they'll cross multiply. So they'll bring the 18 over, and then they'll bring the 12 over. So effectively what you're doing when you're cross multiplying is you multiply both sides by 18, and then you multiply both sides by 12. So that's what cross multiplying is. So if you do that, then that cancels out those 12s right there, and that cancels out those 18s right there. So then you get 18 times 5 is equal to n times 12. And then to get n by itself, you then just divide by 12. So then you have n is equal to 18 times 5 over 12. You can cancel out the 6's, so this is now 3 over 2. So 3 times 5 is 15 over, and then over 2. But you might notice there's a lot more steps kind of being done over here. I am multiplying by 12, multiplying by 18, and then dividing by 12. You don't have to multiply by 12 if you're going to, like, in the very next step, divide by 12. Like, you're just, like, doing an unnecessary step before you, like, cancel out that step. I don't understand why people do this. And I'm more confused why the textbook also insists on doing this. All you have to do is just multiply by 18, and then all of a sudden you have n by itself. Don't understand why people do this. Anyway. I'll get off my high horse. All right, 5 over 12 equals 15 over n. How do we solve for n here? So here, cross multiplying is actually not so bad. Because if you want to get n by itself, so there's like three in my eyes. There are like 3 ways that you could like go about doing this that are like all like equally good. So the first way would be just cross multiply first. So cross multiply, you get 5n is equal to 15 times 12, and then you divide both sides by 5. It's the same as multiplying by a fifth, right? Get rid of the 5, and then you get 15 times 12 over 5. 15 divided by 5 is equal to 3, so n is equal to 3 times 12, which is 36. Okay, so that's a perfectly fine way of doing that one. Let me show you another. Okay, your first step could be to just flip both fractions. So this, if I were to flip the first fraction, I get 12 over 5. The second fraction, I get n over 15. So I'm just taking the reciprocal of both sides of this equation. Technically, there's like a lot of things that are like being done here. Like technically you're like cross multiplying, and then you're also like cross dividing and then you're like flipping both sides of the equation. So technically there's a lot more going on under the hood. then just flip both sides of the equation. But it's a valid thing that you can do. You could just take the equation and then take reciprocals of both sides. Is valid. And then from there, you could just multiply both sides by 15 to get rid of the 15 on the right, and then just get n by itself. Now n is by itself. N is equal to 15 times 12 over 5. And again, the 15 and the 5 can simplify to just 3 times 12. So this is 36. Okay, so those are two pretty good ways of doing it. And then let me show you the last way, which would be to kind of use your intuition a little bit more. So here, these are proportions, right? So 5 to 12 compared to 15 to n. So everything in this fraction compared to everything in this fraction, they also have to be like in proportion with each other. So 15 is 3 times bigger than 5 is. And so whatever n is, it has to also be 3 times bigger than this denominator, right? This numerator compared to this numerator compared to this numerator, they both have to be 3 times bigger. Or getting 3 times bigger, however I said that. And so what is 12 times 3? 12 times 3 is just equal to 36, right? We're just taking this denominator and triple it, and you get 36. That's all there is to it. Okay, cool. Suppose that a bouquet of flowers has 240 roses and 360 tulips. How many tulips would be needed for a bouquet with 15 roses? Do I have like another? Okay, yeah. Okay, so how many tulips would be needed? So actually, I think this is like a good chance for you to kind of stop and see if you are able to solve this problem on your own. So basically what you're going to want to do is set up a proportion and then solve that proportion using this problem. You could do this with unit rates, but setting up a proportion would potentially be easier. So if you feel comfortable, pause it and give it a shot. If you don't, feel free to just kind of watch and see what happens. All right, so we'll set up a proportion. We'll say 240 roses to 360 tulips. This has to be in proportion with our other bouquet. So we need another bouquet that's going to have 15 roses and some number of tulips. Let's use like n to represent the number of tulips. Okay, you could use whatever variable you want there. And so now we have a proportion going on, and we just need to solve this proportion. Okay, so what do we do? So we could do any of those like steps that we did before. We could think like 15 times what is equal to 240. So, you know, this is like a little bit more complicated because you then would want to say like, okay, 240 divided by what equals 15, and then 360 divided by what gives you n, or divided by whatever that is, will give you n. That seems slightly complicated. Another thing that you could do is take this rate over here and simplify it. So that I'm actually going to do that. I'm going to simplify that rate to just 2 over 3 like we did before. So this is like, you know, divide that by 10 and divide that by 10 and then divide both by 12 after that, and then you get 2 over 3 roses to tulips. This is the same proportion from like the other slide. Okay. Now, how do we solve this proportion? So I could bring the n to the other side. I could do like the cross multiplying thing. I just feel like doing the cross multiplying thing here. So 2n is equal to 15 times 3, which is 45. And then divide both sides by 2. So n is going to be 45 over 2, which is 22 and a half. So you have 15 roses and then 22 and a half tulips. So obviously it doesn't make sense to have half a tulip, and so you just kind of round to the nearest number. So probably pick 23 tulips. This one I think is a little bit trickier. So let's suppose that a bouquet of flowers has 240 roses and 360 tulips. So same setup. How many tulips would be needed for a bouquet with 25 total flowers? So here we're not saying that there are 25 tulips or 25 roses. We're saying 25 total flowers. So this is actually going to kind of mess with the ratio a little bit. So now the rate that we need to consider is not tulips to roses or roses to tulips. We need to do tulips to total flowers. So if I'm doing roses to tulips, that's going to be like 2 to 3. But if I'm doing tulips to total flowers, I'm just going to write total. I would have 360 tulips, and then 360 plus 240, which is equal to 600 total flowers. And we have some number of tulips that we don't know yet, and then 25 total flowers. We need to solve for n here. So this is our proportion. We need to solve for n. I'm going to start by taking the left-hand side and simplifying it. So I can cancel out a 10 from both of these. So I get 36 over 60 is equal to... All right, now I can do what? I can divide by 12 for both of them. So divide 36 divided by 12, I get 3. Divide 60 divided by 12, I get 5. So I get 3 to 5. So my proportion now is saying 3 tulips per 5 total is equal to n tulips per 25 total. So now you could just multiply by 25 to get n by itself. Or you could do the thing of noticing, how do I go from denominator to denominator? Well, 5 times 5, my denominators are getting 5 times bigger, so my numerators are also getting 5 times bigger. So that tells me that n has to equal 3 times 5, which is equal to 15 tulips. Okay, and yeah, that's the video. Thank you all for listening. Hope that helped, and I'll see you in the next one.